Developer student clubs train thousands of student developers globally and work with their communities to solve real-life problems. Google selects amazing students from across the globe once a year to be a developer student club lead and start a club on their campus. These leads believe knowledge is power and that technology can do extraordinary things for the world. They take on the responsibility to help students learn and empower these students to solve real problems around them. Join us in building a global community for students.
Hello and good morning, everyone. Thanks for watching, or whoever's right now awake gonna watch this. However, this session will be recorded for you guys to watch it later in case if you missed it. Developer Student Club program is actually one of the Google developer programs for students where students are able to be part of this community to learn new technologies that exist in the current era. Now today we're gonna have a speaker. His name is Chee Seng, where he will be talking about the art of designing, coding and designing. Now let's talk about the speaker today. He's a design apprentice at Stampede. He has previously designed projects which involve industries like cloud, education, and travel. When he's not designing professionally, he'll engage in design and front-end and development in hackathons. He is also the co-organizer for GDG Cloud and Friends of Figma in KL. So let me introduce Chee Seng. Hi, Chee Seng.
Hi, Dapla. Hello.
Awesome. How are you, Chee Seng? Are you doing good?
Yep, doing good. How
All
about
right, cool.
you?
I'm good. I'm good. I'm good. Thanks a lot, Chee Seng. So I'll pass
Sweet.
the floor to Chee Seng to talk about the art of coding and designing, the art of doing coding and designing. So Chee Seng, you can begin.
Right. Right. Morning, everyone. I'm Chee Seng. So, so today my topic is actually about the art of doing coding and designing. So the the story about this title is actually not from the Art of War. It's more on a book that I've came by from Stripe Press. It's called The Art of Doing Engineering and Science and Engineering, either one. So that is how I came up with this very sick title, but not sure whether it's sick later on. But yeah, so what I'll be sharing right today in terms of coding and design, it's not really technical. It's more on storytelling about my journey, doing both of this stuff together, sometimes not together, but you get that point. So it's kind of like my story on how I actually do coding and designing for quite some time. And I guess Dafala has already tell you about a bit of my background, being a design apprentice at Stampede Design, co-organizer for Friends of Figma, Kuala Lumpur, and also GG Cloud Kuala Lumpur. So you may or may not see me before this in terms of design and also Google Cloud events. And lastly, I think here is that I'm currently very into rubber stamp carving. If you are my follower on Instagram, you might see me keep on spamming your stories about the rubber stamp I carve. So I'm sorry about that. Yeah. Right. Let's dive into the definitions. The first one. So design, what is it? Um, Without actually thinking or realizing, I just searched the word design on Google, because even for me myself, at first I asked myself, what is design? I kind of know what I really want to actually, I kind of know why, but I want to see how the general public or Oxford Dictionary actually defines it. So in terms of Google, it gives me a result, which is a plan or drawing produced to show the look and function of or workings of a building, garment, or other object before it is made. So it is like physical uh, product design, or a lot of stuff architecture. So which is, you can see a plan and drawing. That is what Google or Oxford Languages gave me. From my point of view, design is problem solving on a high level. It might not be true to you, but to me, it's problem solving on a high level. Moving on to coding. So what is it? Coding is a process of using a programming language to get a computer to behave how you want it. Basically, writing instructions to tell a machine what to do now, next, and later. So it's writing instructions. And to me, on the simpler terms, it's problem solving on a low level. So it's much more specific at times. Now, these two things correlates to each other, coding and designing. As I said before, designing is problem solving on a high level, and moving on when it comes to coding or software engineering, it's problem solving on a lower level. Doesn't mean that high level is much more stronger and low level it's uh, much more weaker. It doesn't it doesn't mean that. It's just much more specific, or it's much more visualized in a visualized way. I'll explain that in my later sections. So let's begin the story on how I actually do coding and designing together. So the story begins with Tron. So this was a, I think, a command line interface from Tron Legacy. It's a film on 2012, I guess, if I remember correctly. So that was almost 10 years ago, which is also the first time I touched programming. So I saw this interface in Tron Legacy, and it's the Samflin, who is the main protagonist or the main character here. He ventured into his father's arcade, which has its own office, and it's a black touchscreen interface where they prompts the command prompt, which is something like this you see here, and he types in "Who am I?" So Of course, if you try this on Windows command line and also if you're a Mac user terminal, you might see that if you try this who am I, you will actually see a result like tells you who you are, because it's literally asking who am I, and computer telling you back your username, which is maybe for my case it's Chee Seng. So for a 12-year-old Chee Seng, it's really, really exciting to me. It's like, wow, okay, you can do that. I thought it was AI, but it's just some simple command line. But for me, it's very fascinating, and that is how I actually started computer programming. So I actually started computer programming first before I actually jump into design, as you might know now. And my first line of code, quite cliche, it's also a hello world, but it's written in visualbasics.net. It's not really famous nowadays. Yeah, it used to be called VB. That was 10 years ago, vb.net. My message is messagebox.show and then hello world. A similar example is basically a prompt in JavaScript. So you write a prompt, sorry, not a prompt, alert box. So it's like .alert, then you bracket hello world. That's a very similar thing, which is similar to message box.show. This is in VB. So this is my first line of code. And after that, I continue to explore HTML, CSS, JavaScript, even C++. It's hard. C++ was another different level of hard, at least for me, because it's a low level language, and if you're talking about HTML and CSS, it's much more on a descriptive language than a script. So it's technically it is a programming language, but it's much more on the descriptive side. It doesn't write instructions. It describes the web itself. So there's the difference between HTML, CSS, and, for example, JavaScript and C++. Because JS and C++ actually create stuff, HTML and CSS kind of describe stuff which already has on the web. Yeah, so it's a descriptive language. And I continue, and that was me when I think it's between the age of 13, 14, something like that, in high school, and then I stopped. So there is a time where I actually stopped programming, even though it was a long, long time ago. Now I stopped, and then you might see here there's a lonely character here. So that time wasn't in terms of computer software engineering or computer programming, it wasn't really popular back then. And when I say back then, it's 8 or 7 years ago. It wasn't really popular as you can see now. There's a lot of people sharing about inspiration on coding, how you can do better, best practices, simple ways, free code camp, blah, blah, blah. Back then, what many people don't really know, especially in high school, I studied in a national school, government school, and no one actually knows what the hell I'm talking about. So technically, I'm the only one who is coding by myself. So there's no one to talk to about HTML and CSS, web development. I feel very demotivated, and then I stopped because it is not really an easy thing to learn in the first place, and especially when you're alone. There's not much hackathons back then as well. So I stopped, and then after a while, I realized I can draw. I mean, I've always been drawing since the age of 4 or 5. So drawing and illustrating has been a natural thing to me. I just never realized it before that. Even before coding, I thought I was going to be a scientist. I thought I was going to be a computer engineer. That is what I planned to do. I never imagined myself as being a designer in the end, or user interface designer, because that time it doesn't exist. Even web design doesn't exist. Actually, it exists. It's just not as much spoken as right now. So I realized I can draw, and I've been drawing since very, very young. Even before the age of 12, I've been drawing a lot. And I start to explore again the art of doing illustrations. So I still love graphics and I still love designs because these are things that I'm already good at from my point of view, compared to computer programming, which is kind of hard for me. So I kind of pursue it. So I think before that, you might also know Youth Hack. That was a long time ago. GG, GGKL. Back then, there was no GG Cloud. So I joined those community events and stuff like that. And I'm almost always the graphic designer for them because there's not much designer in the tech world, and I'll need to actually do a lot of tech stuff on that end. So after a while designing, I feel like I still love a lot of technology. You can see here there's like servers connecting around. I think it's servers. So still love technology a lot because I have that very common the very good sense on how technology works. When my friends ask me why does this particular program doesn't work like that, why my computer is not working, I tend to look at it in a different way. It's not like just reboot. Maybe you can disable something, re-enable something. Maybe try shutting down this program because it's affecting this program, blah, blah, blah. All the logic behind why certain software doesn't work on a machine, it comes quite natural to me when I'm explaining to my friends when they are facing all these technical issues. So I realized I still do have that minor talent, even though it's not as good as designing. So I'm thinking, should I go back? So in the end, I went back. But this time, because of my previous knowledge on programming, I got familiar quite fast. So I continued HTML and CSS. But right now, with the help of hackathons, it kind of forced me to learn more new stuff. GitHub platforms. I started using GitHub back in 2016, or maybe before that. Last I checked, and also Git, Bootstrap. So these are some of the examples I pull from the web. There's actually a lot more. There's Vue.js, JavaScript. So I continue to actually learn, but this time with a different perspective. Not only learning from a perspective of a designer. So I see things differently right now. It's not as like I need to be a computer software engineer, blah blah blah. But I want to build interactive UI visuals, and which is why you see here the first few things are actually HTML, CSS, and Bootstrap as well. Bootstrap is like a UI library or framework, so it helps in building user interface elements quite easily and fast. And then after that, yeah, things are different. Things are different because now, after a few years has passed, this is like 2017. This time things are different, very different. So compared to what I said in high school, no one cares. Literally, no one cares. To be honest, when I talk about technology, people just, wow, that's so fascinating. Bye. But then when I head into university, the start of my year or college, I never really completed my university or college, I would say. Things are very different. People in your peers are different, are much more specific on web technologies, which is a good thing because right now you have someone to talk to and someone to share your ideas with, and also someone to critique your ideas. So there's a community behind the tech itself. You feel motivated because when things go wrong, you can consult other people, other software engineers, other students, or your peers. Now, why I say things are different when you have a community. Imagine that you are a software engineer working for a few years. You can't get demotivated by the things that you are good at and used to love, because they're just some stupid projects that you don't really want to work at. And in the end, if without a community, you might actually leave your job and go be maybe someone else that you're not really good at, or do something that you're not really good at, but you just kind of feel demotivated while doing coding. And community events, meetups that I went to changes or motivates a certain person to actually continue their journey. For example, continue their journey in software engineering. Because imagine this scenario where you're so worked out on your work and you go to meet up just to listen to their stories and how they work on their personal projects, side projects, maybe even games itself. You feel less stressful because it's not work in the first place, and in the same time you know what they're talking, you share the common language, and you feel motivated again to continue the path, and you know why you're doing what you're doing. So communities are present by that time, and I continued, but this time with a different perspective, with a designer's perspective as well. How can I code from a designer's point of view, and also how can I actually build interactive elements on the web? Because web itself is very flexible. You don't have to download a lot of things. You just have to have a browser, code editor, something like that. Now, a few years passed back until 2018. I decided to focus more on UX and UI. So this is something that is new to me that time. So I was thinking, how can I have a profession that contributes both coding and design? Of course, actually, front-end engineer makes sense. So technically, front-end engineer makes sense, but there's another approach I take, a much more high-level approach besides front-end engineer. So front-end engineer solves the low-level parts of design. From another point of view is that UX and UI designers solve the high-level parts of design. So they are kind of like the architect, and front engineers are like the engineers or the builders of a certain design. So I started to focus more on UX and UI. Then when we talk about UX, this is only a Venn diagram of a UX. So the UX itself has a lot of things to consider, overlapping between user needs, technology, and business goals. So it's not just making things look good. It has to make sense to the user, consumer. It has to make sense to the business, the company you're working for, the product you're working for. It has to make sense to a technology, because most of the time, it actually involves digital products nowadays, because digital products compared to physical products are much more easily accessible in terms of resources. It's not like physical, it's software. So it's very easily accessible. You can get your tools very easily and start working on it, which is why technology comes into place. And then there's also a UI portion, which I didn't show here. But for the UI portion, there's a lot to consider as well. There's motion, there's interaction as well. So even on the design part, there's a lot more things to focus. And I can't just be coding and also designing professionally at the same time, because I have community events I need to manage, so I need to focus on certain stuff. So focusing on a certain part of your life is quite important, as I would say. But I kept coding as a hobby. So if I have time, like today I'm speaking here, I'm most probably gonna code a JavaScript game later on. So I kept coding as a hobby. I do it on my free time, on the weekends, just to actually sharpen my skills. And also, I mostly code in JavaScript because, again, it's very accessible and it's easy to code in it. Just web browser, boom, results are there. Whether it's an error or whether your code is running, it's very easily accessible. There's nothing much you can actually download to actually make it work. Very, very easy. So the web development is like one of the most easily accessible parts for software engineering. So if you are trying to actually get into software engineering, you can actually start web development, because it's not much commitment. There's nothing much you need to download an editor and a browser, and then you're good to go. But right now, editors are very advanced visual codes. There's plugins and stuff. It will help you in coding, blah, blah, blah. There's a lot more things are very, very easy to learn right now compared to what I did last time. started with Notepad++. There are a lot of people still uses Notepad++ for very good reason, but Visual Studio Code is really, really easy and convenient. All right, and then yeah, now it has been 10 years, to be really honest. I'm 22. I started at 12. If you look back, it actually has been 10 years transitioning from coding to back to a little bit of graphic design, and then slightly to digital design, then taking coding back out, and then combining them both. It has been 10 long years, which I didn't realize it, but it's a good thing to talk about it when it's actually already a decade since the first line of code, since I written my first line of code. Now, how does it help doing both? Of course it helps, but how does it help? Now, it helps in a viewing point or a problem solving point of approach. You view things differently. I'm a designer by profession, product designer by profession. I view design problems in a coding way sometimes, or actually most of the time, and vice versa. Coding ways with design, coding problems in a design way. It gives you a very different perspective on how things work. So what I mean by that, for example, take Tetris as an example, right? Now, on the, I'm not sure, on the left side, from your point of view and also from my point of view, on the left side, you can see quite a retro-ish look Tetris game. And on the right side, you can see numbers, or in this case, matrices. It's also a Tetris, but presented in a different way. So on the left side, which is the retro-ish looking Tetris interface, this is how designer will approach stuff. So how can I make this a little bit more better, a little bit more modern or popping, or maybe softer in terms of color, not like too retro, because this is something you can see like in the late 80s or early 90s, or even the early 2000s, something like that. How do I make it much more smoother and popping? So this is how designer approach, for example, Tetris. Now, how you build it is a different scenario. So this takes an example from what I did I think 2 months ago, when I was teaching how to actually build a JavaScript Tetris game. So you look at the Tetris game in a very different way. You look at it as a grid, because in Tetris there's boxes and stuff like that. You look at it as grid, and then inside all this grid, there is a lot of numbers, which actually known as arrays. So you need to apply all these numbers from 0, because array starts at 0, and then it ends at 199. Basically, there's 200 square boxes here. Now, this enables you to think on an engineer's perspective instead of a designer. How do you make each block goes from top to bottom, and how does it work like that? So in this case, how for example, how this red block comes to the bottom, it's basically basic arithmetic, basic mathematics. It's like this block plus 10 plus 10 plus 10 plus 10 and updates. So because 7 to 17 down below, 7 to 17 is actually the difference between a 10. So and then 17, 27, it's also a 10. So in order to move down, for an object to move down, the calculation needs to be plus 10, plus 10, plus 10. And if it's moving right, it's plus 1, because it increased by 1. So each block increases by 1 in terms of its numbers inside. So this is how we think, how we approach a certain problem. So the different perspective gives you a different perspective when you know both design and coding. So in design, you focus on the visual side. How can it look like? How can it look suitable in this modern era, or how can it look suitable for certain audience, something like that. And on the implementation side of things, how does it work? How does it how each of the blocks work? How does each of the block interact with each other? So for example, the blue ones are the ones that has already been stacked, and how does the incoming one interacts with the stacked ones? It doesn't just goes off grid overflow, right? It needs to stack up and then being replaced. So this is there's a lot of kind of different thinking goes into it when you're a front end engineer, something like that. Another thing, another thing that is another good thing about doing both is that the more you know, the easier for others to learn from you. Now, this is also two example, a designer's example and also front engineers example. Because that I keep mentioning front engineers because that is as far as I go. I'm not really too sure about how back engineers work because I didn't really do that before. So, oh shit. All right. So let's look into the left one. This is an example I screenshot from my Figma file. So we're talking about components and instances here. And on Figma, there is always the master component, which is the thing you see here. There's a diamond here. So this is a master component. And then there's instance, which is a duplicate of a master component. So if I change here, let's say I change this number 1 into 2, it might affect here as well. And if I change the color of this block, so this is a dark gray, I change the blue, it will also reflect it on the instances. So instances is like a copy of the master component. Now, that is what we know as designers because we work on this design tool Figma. Now, for engineers, it can also be explained like this, constructors. So in this case, I took it from W3C school. In this case, there's a constructor, which is technically a component. If you are trying to explain some like this part to a designer, you can kind of explain it this way. It's technically a component, a master component. So inside this constructor, which is also an object, there is a first name, last name, age, and color. And then you have instances or objects. So instances is kind of like the same thing, which happens here in Figma. So every new instance, that's John, Doe, 50, Blue, anything you want to name. There is still a difference, but on a higher level, when you explain stuff, when you try to explain this part to a designer, you can use example from a designer's perspective to describe coding scenario. So it makes explanation and also learning from you easier because right now you can explain things that is outside their boundary, but at the same time make it familiar for your peers to know. So even for engineers and themselves, you want to explain design to engineers, it's kind of like the same thing. You have components and instances. It works kind of the same as constructor and also an object in JavaScript. So there you have it. So you might kind of impress your colleagues. Oh wow, you know so much, but it's actually pretty direct. Yeah. And learning about how design works is easier. So there are a lot of times when we need to look into how certain web pages or landing pages looks like, how it's built. If you do not know coding, you don't know how to actually target specific elements or models on the web. You don't know how it actually works, how it's measured, the structure of the component. So for me, I always tend to look at it on a high level, which is the normal interface. It's like, wow, it's really, really nice. How does it work? How does it interact with each other? Then I kind of command Shift C, inspect tools to inspect each of the element myself. How does it work? How does the color works? Because in some of the modern websites, they actually implement a lot of gradient effect, which can be coded in CSS as well. So that I'm actually really fascinated by how it works. So I actually open the inspect tool and check and also disable, enable all these properties of CSS to see how it affects each other if I disable or enable it. So when you're a designer, you kind of know this is how the web works, how each of the object model works. It opens up a new world and also a different perspective towards digital products, not just looking at it in the high level or visual side, but it also looks at how structures part, how it interacts, what happens when it clicks, what kind of things that it triggers, how it interacts on the lower level. That gives you the different point of view when you start to design for a different project. Then you know how you actually can talk to other engineers as well. So reading documentation is also more fun because sometimes documentations aren't really that fun to read if you're only a designer and trying to learn. But if trying to learn about coding, if you already know a little bit more about coding, you know how elements interact with each other. You can imagine. You read the code, you can imagine the box goes here, goes to the left with this certain command. You can imagine it's also more fun because right now you can imagine how it works and how it interacts with other elements on the web. And understanding what front-end engineers say, at least some of it. I mean, front-end engineers is a very, very big role. It's a very important role. Not everything you know. You don't actually know everything from a front-end part if your focus is on design, unless you're really trying to be a design engineer or in other cases a unicorn, which is what I'm trying to be actually. But there are a lot of things on the front end world which is quite still unfamiliar to designers because those are quite I would say lower level in terms of front end design, but it's very important if you're a front end engineer. So even though those are some of the very important stuff, you know what they talk about on a high level, so you can interact with front end engineers well. You know what they're talking, and they also respect you more because right now a designer knows their pain. At least they don't design stupid stuff, but of course it's very debatable sometimes because it's not about why design stupid stuff. It's more like whether it takes time to implement it stuff. So yeah, that is my point of view. If you're unable to implement it, maybe sometimes your skill is not there yet. That's what I say. But in general, understanding what front end engineers say is good, and the discussion between an engineer and designer has also improved in quality. So there's much more meaningful discussion instead of why this works like that, blah blah blah. You can actually ask how it can work like that, or maybe try this interaction because you know a little bit of coding already. So the way you discuss with engineers changes. Instead of trying to know everything, you are trying to test what's possible. So discussion changes, and there is just a lot more that you might find out if you're trying to experience design and coding. And most importantly, because right now you know what both both role does, at the same time you also do it yourself, you can actually inspire more craftsmen and craftswomen from both design and development mode. Why I say something like that? Because I came from a development background, I know a lot of software engineers and also developers in the first place, and I transitioned to design. So I kind of also know a lot of people from design, but both of them don't actually really get to know each other's background really much. But when you know both sides, you kind of can explain to them how the opposite world works, and they might be interested in it. You can inspire a designer to look into how design actually works, and you can also inspire how engineers in terms of how design is created, why it needs to look a certain way, and why a certain color needs to be implemented this way. Because sometimes engineers are very focused on functionalities, they don't see it on a higher level. If you know your designer or an engineer together, you can explain it in their terms, but also introduce some of the design concepts to them. So again, you really will inspire more craftsmen and craftswomen from both sides of the world. So it's a very powerful skill if you actually do it, and it's also fun in a way. In a way, not every time is fun. And yeah, I think that's all from me. So I'm happy to take any questions if you're unclear. Have you mute your mic?
Oh, sorry. Yeah, actually, connected my mic.
All right.
Thanks, Chee Seng, a lot for basically giving that session. Those who are basically watching, this is a Q&A session, so please do ask questions. We do have one question here by Shravan Kumar. He basically asked, how does one be a UI UX designer?
Let me think.
Okay.
How does one? I need. How does one be a designer? I don't know. I feel like it's just be a designer. How does one?
Yeah, maybe I'm
really think about a good answer.
Yeah, okay. Because if I were to rephrase the question, maybe he's asking how do you start off being a designer? Because you need a lot of experience to get there, right? So.
All right. Now, okay, I'll start a little bit by setting up the context here because I don't just want to answer how does one. So, UI UX designer as a role itself is a very, very new role. It's kind of like we're talking about software engineers because software engineers nowadays are really, really popular. So, and of course, UI UX designer is rising also. Now, there is a difference when we talk about graphic designers and UI UX designer. And the reason is that if there's no difference, then there's no reason why it's named graphic designer in the first place and also UI UX in the second place. On UI UX part, it's much more focused on the technology side for now, as you all are very familiar with. But UI UX doesn't only involve software, even though you are familiar with the term appearing in a lot of tech companies, but it is not limited to software. User interface and user experience applies to almost everything around the world. Product design involves business as well. How do you become one? I would say, you don't become one suddenly. It takes time. What I think you can start with is identifying potential problems around you, potential design problems. It can be visual. It can be it can also not be visual because design is not graphic. I need to mention that again. Design is not how it looks. It's actually how it works. So there is a slight difference between graphic and UI UX design. Although a lot of people perceive it as how it looks, but it's actually how it works. Because design is not art. Design is art, but art is definitely not design. Yeah. So that is what I said. And again, going back to one of the few points I've introduced earlier is designing is solving problems on a high level. So if you want to start, becoming a UI UX designer, you might want to again notice problems around you. What I did was I walked into a mall. How does the kiosk works? This is actually a very easy example to say. How does a kiosk works? The kiosk should work as a directional, right? So it takes people around a shopping mall. Now you can start playing with it, and then you might notice how it helps people or shoppers around, or how does it not help. You start to find the pain points of why it's not helping and why how you can improve it. Then you start from there, and from there you might actually research a lot of design methodologies. I can't state a lot because there is just a lot. I think it's more on the preference side, so you might find out yourself. But I would say generally start with a problem. There's a lot of problems in the world, so yeah. start with a problem and start solving from there on a high level. You don't need to think about how it works. Like if I do this, whether it's implementable. You're a designer anyway. You can go crazy until
Right.
you start caring about implementation. Then it might limits. Yeah, but if you want to start off, I think it's a good thing to look into problems around you. Yeah.
All right. That's actually a nice one to say. All right. So I hope that answers your question, Shawan Kumar. Moving on to another person. We'll basically ask Lawan, boss, how do you keep up as a software engineer and a designer at the same time?
So as a software engineer, I don't. Now, one thing, actually, I don't. To be really honest, because I also state that I code as a hobby. I don't do it as a profession, so that's a good thing. Uh, yeah, that is basically my answer. I don't code professionally. I do it as a hobby or in a hackathon. It keeps me it keeps me notified on the technology and implementation side because again, if you're not doing that, especially you're UIUX designer on software and yeah digital products, I think you need to be aware of what's possible in terms of the implementation side. That's why I keep on doing that as a hobby to be informed of what's the latest implementation, what's possible in terms of front end development, blah blah blah. But I don't do it professionally, so I don't really keep up because I don't do it professionally. So that I think that's your answer. Yeah.
All right, cool. All right, we have another person asking a question. What inspired you to be a designer?
What inspired me? I mean, firstly, I love design. That is basically a very that is basically my answer. Again, design is problem solving.
Right,
It might be hard in the first place, but when you are able to solve a problem, you see because problem in general affects other people or other users. You know that if you solve a problem, other users are happy, other people are happy about it, then you feel inspired as well. Because you know that. If you don't know that, then there's no point. You also know that whether your solution is solving a problem. So that is, I would say, kind of weird from my part. It's also inspiring, even though it's not solving a problem, but you know what's wrong with your problem, and then you continue to improve it. Sometimes it's demotivating depending on situation, but most of the time for me, I tend to focus on how I can improve my current solution to be better instead of just griefing about why does it make a user much more angrier. Sometimes it does, depending on situation, but I stay inspired by how it solves a certain group of people's problem and also why doesn't it solve a certain group of problem. Yeah.
right. All right. Next question for you. Do you apply design thinking framework in designing things?
Design thinking. I mean, I think yes, because I think in Stampede Design, which is a company I'm actually in being an apprentice for, we are very heavy. We breathe, live, and eat design sprints every single time. So design sprint is kind of like our bread and butter here. And sprints are introduced by Google Ventures in the first place. It has. Do I have a book on? My book is not here. So it's actually from Google. It's actually created by Google Ventures. It's a book on design sprints and how. I think that's basically one of part of design thinking, and yeah, I do apply that. We do apply that as a company, as a whole, as a company. Yeah, but I wouldn't tell you that I use design thinking, a specific design thinking framework because there's just a lot out there. And in general, I can't recommend you unless I worked on a project because it's very specific towards a certain problem or scenario. And and design thinking in general, it's just basically things like a designer because designers things out of the box, blah blah blah. And anyone can think out of the box if they're really trying to, but it's it's just a way of thinking and problem solving, I would say.
Right.
So, well, but structured way, I would say structured way. If you're looking at an answer, I do apply design thinking framework, but there's a lot out there. It's depending on situation, I would say, to use.
All right, cool. Hope that answers your questions, Fidel. Another question from the same person just now. What are your first principles in creating designs? How do you know when to stop optimizing your designs?
Ooh, it's a hard one.
Yeah.
Especially the optimizing part. Very good one, because I mean it's natural where you try to perfect designs.
Yeah.
And then there's deadlines. First principles. Depends. Also depends. I'm gonna use depends as my trump card here, but okay. So first principles in creating designs. Does it solve a problem? That's a problem. Is there a principle? And maybe it should be a goal of every single designer. Does it really solve a problem? And again, going back to the Venn diagram I've shown, it's simple enough that I can describe here. Business, technology, and user needs. These are some of the things that UX is overlapping on, and UX is trying to solve. If you can balance all that together, then it might be a good design. Might be, because depending on external situation as well. So that's that. How do you start optimizing on it? This is a very hard question. Depends on timeline. Actually, it depends on timeline, to be honest. If you're designing professionally, there's always deadline, and Stampede is an agency, so it works a little bit different from a product company. I used to work in a product company, so again, for product companies, we also focus on the MVP, minimum viable product. If you are not familiar with that word, you can search on that. Minimum viable product. It's a product that works, but it's like kind of like version 1 of this product, but it works. It solves the problem. How does it solve it efficiently? Not too sure yet, because it's version 1, but it solves the problem. So optimize, I think it comes in experience. You need to know when it's good enough, when it's a MVP version of that particular product, and then you launch it to see what happens and how it affects. How does the crowd react to it? And again, there's always the deadlines and timelines, so you can't be focusing on perfecting a certain design too much, and unless you're really confident that this super perfect design is going to work. I mean, not everyone is like Apple. Apple has money and time. So most companies don't have. So that's that. Yeah. Depends on your experience as well, and also the company's timeline deadline. If your experience is good, you can optimize it faster and also with less time. But at the same time, you always need to manage the time. Yeah.
All right. Another question by the same person. How do you convince software engineers to do your design despite them being technically difficult to do?
Technically difficult to do. Actually, this is a good question, which most probably a lot of people should know. But okay. Really convince. I don't. I don't really convince them. Okay, first of all, yeah, technically I don't really convince them, to be honest. Simply because they know me they know me being as a low-key software engineer myself. And they kind of know what I'm taking. And in the same time, because I kind of know, I know a bit of coding, the design I do is still kind of relevant to them, to be honest. So, which is why I say I don't really convince them. It's more like discussing how does it really look like, how does it really work here if I really want to do it like this. Not commanding, not commanding, not commanding. It's more on discussion. It's more on discussion. Because if you try to convince let's just say that if you're trying to convince the software engineers to implement the designs that you've designed, right? First thing you need to know is that does it take a long time to do it? If you're only a designer and not an engineer, you really don't know how it works. How does it really works technically to build it? Because you do not know the resources, you don't know how code works, you don't know blah blah blah. You can't even predict it. If you know a bit, then you kind of predict it. Sometimes designs takes longer to build because it's necessary. Sometimes it is necessary. I wouldn't say that when you design something and engineers say I can't do it. There are certain cases they can say that, but there are also a lot of cases which I think they need to spend more time on doing it, because let's just say take bigger companies like an example like Apple or Google. They always invent new stuff, right? I mean, in terms of software. Now, imagine that the engineers tell the designers, I cannot do this. You won't see a lot of cool stuff from them. That is the thing I'm trying to point out. When design is not implementable, it's actually more on the skill and time being taken to implement it, rather than I just cannot do it. If you just cannot do it, then it might be a problem, to be honest. But in the same time, there's a balance between design and development, and also timeline. Timeline is a third factor. How fast it should be shipped, whether it's really important to be done as soon as possible. There's a leverage between implementing what has been designed, and also whether it's very, very necessary to do it. Again, I don't really convince them. There are times I try to convince them, because I think that, for example, colors. To be honest, it's just colors. But to them, it's just lazy to change. But for me, there are points that if you don't change the color, it will affect like this, like this, like this. So there are engineers can't see it that way. So you might need to convince them, even though it's a really easy job to them. Sometimes there are really there are people that it's okay lah. It's just a very simple thing. It doesn't affect much.
Right.
But from designer's point of view, it affects much, and you need to tell them why it affects, how it affects. Then they are convinced. Oh, okay, fine, I'll do it. So there is convincing in the situation, but not on commanding. I mean, commanding is a very different term. It's like, even though they don't like it, they need to follow it anyways. I'm trying not to do that, but yeah.
Yeah. Okay. So we also like have like another last question, which is basically by Vigneswaran, where he mentioned, as for starters and beginners, what kind of backend and front-end language do you encourage? I mean, I pretty much feel like this question is also meant for students who wants to start. So what do you advise them, and based on your experience,
I can't advise on the backend part because I don't touch it, to be really honest. So that answers one part of the question. I can't advise on the backend part. For front end part, depends on your level, I would say. If you are a little bit familiar with front end languages already, or even basic HTML, CSS, and JavaScript, you can look into Vue. I'm a huge fan of Vue for some reason, because it's easy to learn, at least from my point of view. It's written, and Vue 3 just came out like today, I think. Yeah, do check it out. It's a JS library. So, but before you jump into libraries, I do recommend you to code a little bit more on vanilla JS, which is pure JavaScript. So it teaches you how coding actually works, how the logic works, and without the help of any libraries or extensions or blah blah blah. Because when you start with libraries, right? When you're a beginner and you start with libraries, there are a lot of things that you do not know, but it works. The problem is you do not know how it works. Take Bootstrap as an example. Bootstrap is really, really easy to do. And when you're used to it, you're really used to it. Then you kind of ignore like the fact that how certain components interact with each other, because you just used to it. It's so easy that when you create an HTML file, You just declare the class. It's so easy, right? Because the class name is there, blah, blah. Declare class, object appears. But how does it appear? How this object is being built? You don't know. That is the thing that I think a lot of people tend to focus less on. And not a lot, I'm not sure about, but if they're comfortable with, I feel like they should start being not comfortable with it and start to look deeper into coding, because it teaches you how to think, computational thinking. JavaScript itself, again, JavaScript is very accessible because of it's a web language, web scripting language, and yeah, it is a very easy to get started language. So before jumping into front-end libraries or framework, I do recommend not learning from scratch, start building projects, because depends on person. I'm not a tutorial person. When I say not a tutorial person, it's like how to build variables, how to declare arrays, blah blah. After an hour, I forgot how to do that. Yeah, because it's very instructional. It's like chapter 1 this, chapter 2 that, chapter 3 blah blah blah. But if you think of it as a project base, you know that, okay, let's say today I want to build an Airbnb clone. Airbnb clone's object should look like this. How do I do that? Then you remember the process, because you know what you are trying to build and how you build it. Indirectly, you're learning all this array variable stuff already, without thinking or caring too hard on remembering the code. A lot of people try to remember code, but Google exists. Don't remember, just Google it. Yeah, but of course, last time the programmers are very, very hard. Yeah, look at books instead of Google's. That's one thing you can try to imagine last time. Yeah, but again, you don't need to try to remember it. You just need to be familiar and be natural with it, because there's always logic behind coding. If it doesn't work like this, then there is a reason. Yeah, that's how I solve it. So for example, this line of code doesn't work. What does this line of code actually do? So if it's not doing its job, then how which area is affecting? So this is how I think on the problem, and you might be able to as well if you try to solve bugs issue in a pure coding language instead of libraries. Libraries are easy. It's like, if libraries don't work, then it most probably is not being called. Your library is not being called, or your file organization is different, blah blah blah. There's a lot of stuff, but knowing how to code pure languages, it's a very, very powerful skill, because you know more about how code works. Yeah.
Right, cool. Thanks a lot, everyone, for asking questions. Thanks a lot, Chee Seng, for your talk and for asking questions. The session is actually already ended. Thank you for everyone who basically managed to listen to this talk. For those who did not, it's okay. You can this particular session is recorded. You can check on YouTube and Facebook. If you have any questions, I'm pretty much sure you can definitely ask Chee Seng. Chee Seng, you okay with that, right?
Yeah.
You can actually ask questions in the comment section or what. Pretty much sure Chee Seng will answer your questions. So for that, thank you so much, everyone. I'll show you. There's actually a video for basically what the DAC is, and yeah, that's about it.
All right. Thank you, everyone.
Just get the video.
Developer student clubs train thousands of student developers globally and work with their communities to solve real-life problems. Google selects amazing students from across the globe once a year to be a developer student club lead and start a club on their campus. These leads believe knowledge is power and that technology can do extraordinary things for the world. They take on the responsibility to help students learn and empower these students to solve real problems around them. Join us in building a global community for students.